This is a video that goes into more detail about using the IRSA tool called IRSA Viewer. You may launch the IRSA Viewer tool from this icon on the front page, but you may also encounter it in search results like this, where you have a link that says To IRSA Viewer. If you click on that link, it will launch an IRSA Viewer session with the search results loaded into it. But most often you probably get to it by clicking on that icon on the front page. When you start IRSA Viewer this way, you initially get dropped into the results page. But in order to have any result, you need to upload a file from disk, search for catalogs, or search for images. Let's go to the Images tab. From this search screen, you can load FITS images, create a 3-color composite, or load a HIPS image. HIPS images are fundamentally different than FITS images for a variety of reasons. HIPS images are dynamically adjusted spatial resolution, so they can cover huge areas of sky. I'm going to start with a HIPS image here. You can load HIPS images from anywhere on the web, but I'm going to start here. Note that you can use NED or Simbad to resolve the name. I'm going to put in M16 and it echoes below the box what it thinks I've said so that I can be sure it's understood me correctly. You can put in a field of view if you want, but I'm not going to at this point. By default, it gives you a set of relatively few IRSA relevant HIPS images, but if you want a much longer list, unclick this box and then you have many more to choose from. This table, like all other tables in this tool, is searchable and sortable, but I'm going to leave it as IRSA featured because it's a more tractable list. And then I'm going to select the Herschel-Pax image. Search. This is the Herschel-Pax image. Now, you can see that it looks relatively low resolution here. Watch what happens when I zoom in. You can see the resolution dynamically change. That's the power of HIPS images. But there's definitely a point at which the resolution just doesn't get any better. That's because there's finite resolution for the Herschel data. Now, from here, if I want, I can add something called a MOC, a multi-order coverage layer. By doing this, it's another way of showing where there's data and where there isn't. If I add the MOC for this same data set, you can see that it's showing you the outlines of where the data are. You can see Herschel wasn't an all-sky survey, so there aren't data all over the sky. There's only data in particular locations. Let's add another MOC layer. Let's add the Sloan MOC layer. That is really complicated, so it's going to take a couple seconds to go grab it and then render it. So that is the MOC layer for Sloan. Let's zoom out a little bit so that you can see where it covers it. Zoom out a little bit more. In fact, let's actually put it on galactic view. We can zoom out even further. So you can see the Herschel footprint, the Herschel MOC, is complicated, but so is Sloan. So this is the reason that MOCs exist in the first place. It's part of data exploration so that you can see whether or not our target, M16 in this case, has data from Herschel or from Sloan. If I continue to add MOCs, this is a way of telling where I might find data. Let's go up to the layers icon and remove some of these MOCs just because they are big and they are complicated. Let's go get some more images. This time, let's add some FITS images. It remembers that we searched on M16, but for FITS images, we need to ask for a relatively smaller region. We need to put the units in first and then the number. Now, the next thing I need to do is pick the data that I want, and there is truly a dizzying array of choices. The filters here on the left are critical for weeding down the overwhelming number of data sets that you have to choose from. Let's filter it down so it's just WISE. Let's pick WISE, all WISE, because I know that WISE is an all-sky survey, and I know that WISE observed M16. Now, let's look at Spitzer. Spitzer is still pretty overwhelming, but I know that M16 is in the galactic plane. So I'm going to filter this down to just the galactic projects. If I didn't already know a lot about these projects, I could click on the eye with the circle in it to find out more information about the individual projects. But I do know about these projects, and I know that GLIMPSE is a survey of the galactic plane, which includes M16. Okay, let's go back. And now let's filter just on near infrared. 2-mass 6-degree mosaics is another really good choice. Note, not 6 times, but 6 degree. When the tiles for the 2-mass all-sky survey were created, computers were slower, as was the internet. So the tiles for the all-sky survey are actually pretty small. So especially since we want half a degree, we really want the 6-degree mosaics. Okay, search. It comes back with all of the fits images locked together for color table and stretch. So that if I pick a different color table, it changes all of them together. Note, however, that the hips image doesn't change. For the hips images, the color table and stretch, for the most part, are set by the person who made that hips image. So you have some limited control, but not a lot. Not nearly as much control as you have over the fits images. But you can see right away that all of these images are not oriented in the same direction. So I'm going to click on one of the all-wise images and then go up here and choose Align Unlock by WCS. And now everything, even the hips image, is aligned in the same direction with the same field of view. And you can see right away that Glimpse generated their tiles in galactic coordinates, but WISE is in RA and DEC. Now you can zoom in and out on any of these images and they all zoom together. To make them fit, you can use those. Now you can look at the images many at once like this, or you can look at them one at a time, and you can scroll through the list or have it scroll through the list for you. I also want to highlight this slightly different view. If I go to this view and then tick Scroll Images, I get a multi-image view, but they're bigger than the tiny tiles. One potential gotcha, though, is especially if you're working on a Mac like I am, you have to really look to see that scroll bar all the way on the right. But this image right here, you see how this one's selected? It's outlined in brown. If I use the mouse here, thinking I'm scrolling, I'm not scrolling, I'm zooming. So you need to make sure that your mouse isn't in the selected image, or you can grab and drag the scroll bar in order to scroll through this view of the larger images. You can also get a list of images. For most of the images, all of the fits images that we have loaded, there's a wavelength attached to them. And this table, like all the other tables in this tool, is a Firefly table, so it's filterable and sortable. If I click on the wavelength header, that it sorts the table by wavelength. And look, it has also sorted the images by wavelength. It doesn't know what to do with the Herschel image, but all the rest of them are now sorted by wavelength. All right, let's go get a catalog. Let's go to the Catalogs tab. This tab allows you to search IRSA's holdings. You first have to select a project. WISE is fine. Then you have to select which catalog you want. The all-WISE database is fine. Then you can do a search. Rather than a cone search, I'm going to do polygon. And now it's picked the corners of the image I had selected when I initiated this search. It's gone off to find the catalog, and it's found 5,300 sources. It's made a plot of the catalog here. By default, it's just got the positions, because it's a pretty good bet the positions exist in any given catalog, so it's a pretty good default plot. And it's overlaid the catalog on the images here. Now, because there are 5,000 sources, the plot that it makes is one of these binned plots, where each one of these points can represent more than one row from the catalog. Moreover, if we look here, the catalog too is represented in a hierarchical catalog view. If you zoom in, it will show you every source in the catalog. But if you zoom out, it starts to put the sources in tiles. And the further out you go, the bigger the tiles get. If you scroll in, eventually the tiles get small enough that you see the individual sources. You have some control over this. If you go here, you can change exactly how it's showing you those cells, how many sources is needed for a cell, and what size those cells are. You can also change the color. If the pink is a little too hard to see, let's make it more of a magenta. That might be a little bit easier. Note too that there's a color swatch in the catalog tab. So if we go and get another catalog, let's pick 2mass. Do the same polygon search. This time I have 24,000 sources, and it's still overlaid. If we zoom out a little bit, eventually we'll see cells for both that pink WISE catalog and the purple 2mass catalog. And you can see the numbers are offset, so that you can see in this cell there's 45 WISE sources and 219 2mass sources. If you zoom in, though, eventually you reach the point where both of the catalogs are shown. Now you can do some pretty sophisticated things with these catalogs. Let's add some filters. Now the signal to noise ratio in J, if we make this greater than 4 and make the H signal to noise greater than 4 and make the K signal to noise greater than 4, now we're down to 9,000 sources. In WISE, let's see if we can do a similar thing. WISE 1 signal to noise greater than 10. Y is 2 signal to noise greater than 10. Y is 3 signal to noise greater than 10. And Y is 4 signal to noise greater than 10. Now we have many fewer sources. And you might have noticed that the images are jumping around. That's because we have something called pan by table row selected. So that if I click on a source in the plot, then it jumps in the catalog and in the image. If I zoom in really far, the jumping becomes much more obvious. Let's go here. It's that centered source and that row in the catalog. We can change what's plotted too. So for this, since it's a Y's catalog, let's make a Y's color magnitude diagram. So W1M Pro minus W4M Pro. And then for the Y-axis, W1M Pro. And then we want the bright object at the top, so reverse Y, apply, close. Now we have a Y's color magnitude diagram and a nice bright red source there. It's that one and that row. Let's see if anyone cared about this source before. Let's go to this. This is supposed to be a microscope, but I sort of think of it as like an action thing because it's got this drop-down menu. So I can do additional searches based on this row. So I've got this row. Let's go here and let's go to and search Sinbad at that row. Has anybody cared about this object before? Indeed, somebody has. And there are 78 references on it. So you can do all sorts of complicated additional searches. I can go and put the Sinbad results into this tool. I chose the one that puts the Sinbad results in a separate window. You can go and get additional catalogs and additional images or upload the entire table to something called a tap search. We'll talk more about that in a minute. So there's lots of springboards that you can use from here. You can also do that sort of search from the image. If I pick a cone search like this, then I have that same kind of pull down menu where I can launch additional searches based on things I see in the image as opposed to things I see from the catalog. Now let's say I want to save this plot, by which I don't mean save to disk, I mean hold on to it for the moment. Do something called pinning. What that does is it holds onto this chart. And I can go over here and make a plot of something different. Let's say we want to do Ys1 minus Ys2 on the x-axis and W3M Pro minus W4M Pro on the y-axis, and then apply, close. Now we can pin that one. Now we have two pinned charts, and if I make the charts big, I can see them next to each other. When I'm viewing them in this zoomed out mode, it takes the axes away, because if we put the axes on, it turns out the axes take up an awful lot of screen real estate. So if you want to see the axes, you have to look at them one at a time. But if you want to see them next to each other, if you're making two different plots of two different catalogs for two different regions, seeing them next to each other, you can control the range of the plots and make them exactly the same. Then you can view them next to each other. The pinning basically allows you to hold on to them within the context of the tool. And if you continue to filter or manipulate the table, then these plots will continue to update. You can also add columns to the tables. So for example, I've imposed a signal to noise filter here. If I add a column here that says high SNR, then I can use a preset function and say I want to keep the set filtered rows to true and the rest to false. Add a column. Now I have a new column that's called high signal to noise. So if I cancel these filters, then there's all sorts of problems with those plots because it's trying to plot numbers that don't exist. But I can recover that multi-column filter by simply filtering this down to only keep the true, and then the plots come back because all of those values are now viable values. There are some additional ways of searching catalogs. If you go to this, which is sometimes called a hamburger, you can see there's additional tabs that you can activate. Data collections is another way of searching some of the delivered data sets here at IRSA. The way that this tool works is it gives you a HIPS image here. Let's actually zoom out so that we can see more of the view. The region that we care about is down here. The data collection that's first on the list is Large Galaxy Atlas. So it's not going to have any data for M16. But if we go through the list, Akari is an all-sky survey, so it's not going to have those mock footprints. But if we scroll down the list here to Glimpse, remember Glimpse was the galactic plane survey? You can see the footprints here show you quite vividly it is a galactic plane survey. So you can go through here and interactively decide which one of these data sets might be worth exploring more. You can again hit the eye with the circle to learn more about any of these projects, but you can also search for additional data through here. You can launch the additional search using this search here. Let's go, say, to IRSA. That's another all-sky survey. Let's search. And then we have the search results here are going to tell us that it's found several different images from IRSA. That data collections tab is just another way of searching the deliveries here at IRSA. VO TAP. So VO is Virtual Observatory, TAP is Table Access Protocol. This is a more sophisticated way of searching the same catalogs that you get from here. It's just a more sophisticated interface. Using this GUI, you can configure a relatively complicated search and then click this button and it will generate the ADQL that you need. So if you're new at ADQL and you need the ADQL so that you can drop it into your Python code, this is really useful because you can use the UI to configure it exactly the way that you want it and then use the tool to help generate the ADQL. If we go over here, the multi-archive VO TAP no longer limits you to just the IRSA services. You can pick any TAP service from all over the world and it will give you access to the tables that are available at that other service. And you can do a huge variety of searches using this interface. The multi-archive VO cone search is much simpler. It is just a VO simple cone search. The CADC VO OBSCOR, that's a particular kind of search. CADC is the Canadian archive. OBSCOR is a particular kind of search. This allows you to search all over the world for data, additional data that are out there. In this case, it's remembered M16. You can also do the same kind of search if you go to the multi-archive VO TAP. If you go to CADC and choose OBS TAP, that's the same. That's an OBSCOR search. Let me not forget, of course, that you can also do a NED search within this tool as well. To reset all of those tabs, you can hit Reset All, and let me highlight that you can change the layout. If you'd like a different layout with tables in a different place and the plots in a different place, you can do that. And you can choose dark mode or light mode or have it just reflect whatever your system is using. Each one of these panes has a toolbox. So the images have a toolbox here. And whether you're looking at HIPS images or FITS images, you will have a different choice of tools here. The charts have a toolbox here, and the tables have a toolbox here. In each one of these panes, there's a diskette, although sometimes it's a little buried, in order to save whatever it is that you're looking at. You can save it as viewed or save the original. You've seen some of the tools that enable me to do things with the images, with the plots, and with the tables. There is, of course, online help as well as context-sensitive help throughout the archive, but there are also videos that go through the toolboxes for each one of these and go over a basic introduction to images, to plots, and to tables in IRSA tools.